Hi everyone. Gonna continue talking about functions today. So we briefly touched on it on Tuesday, talking about why functions are kind of important, but we're gonna go into some more of the details about some of the more advanced uses of functions today. Functions, reusable pieces of code, write once, use many. So we looked at this on Tuesday. So just think of a function at the very, very basic level again as an alias for a piece of code. So this code right here, both of these lines, they could be over here, right here, but they're not. So when we say my function, remember we're going to, okay, so when we're running our code, we're obviously starting at the top of main. So we'd start here, execute this line, come to this line, my function. Remember we're going to, when we see that, we're going to find my function, jump up here, start execute this, execute that, and then finish, come back here, and start executing the line after that function call. So let's just update this here. Let's say we're Thursday now. Remember with functions, so we'll just run this again. So this printf is called right before we enter the function. These two statements are printed inside of the function, and this is printed after we exit the function. Now, again, one of the main points of functions is reusability. So I can take this, I can just copy it down, run it again. So the same thing is going to happen. We're going to start here, see it the first time, go up, run all these statements, come back, execute the statement after this. So come here, so we see this, we go up, we execute all these statements again, and so on and so forth. So run it again. So you can see that's the entering the function right there from that printf. This is the first time we call the function. Both of these are outputted. This is the second time the function is called right here. That's the result from the second time the function is called. And then finally we're notified that we have exited both of the functions. So when we're thinking about doing something like, let's say we want to do something like print a line. So we'll just have a program which all it does is print a horizontal line. So that's completely possible. Let's obviously recompile that. And it prints a line. But let's say we want to print a bunch of different lines or something like that. Instead of saying this a bunch of times, which it works, it certainly does, what we can do is instead write a function, line, which prints our line. Now, the key reason we would want to put this in a function, okay, so let's go back, let's do this a bunch of times, line, line, line. So that'll print 3 lines. Now the reason we would want to put this in a function, aside from just keeping, I suppose, using less code, using less characters, is let's say we wanted to change our line from dashes to another character. Let's say we wanted to change it to equal signs or something. We only have to change this one piece of code inside this function. So we only have to change it one time. Whereas if we, instead of putting this inside a function, had it right here, we had a bunch of them here, we have to go through and change each individual character in all of these different lines. So we get to repeat things without any of the cost of actually retyping any of the code. So that's those are the 2 reasons we want to use functions. So breaking things up into smaller chunks so you know exactly where things are. And then when we want to make modifications, we can modify the function which is actually doing the work versus having to necessarily modify all of the code. So that was our basic functions. So talking about this more, so when we're looking at our main function, so remember that the main function is where our program starts its execution. So The system will find this main function and it will execute all of the lines of code inside the main function. So when we use main, that's just, think of that as just the entry point. So looking at our main function, it has a return type, so a type of data that it's returned from the function, and then it has these brackets, and inside those brackets will be parameters to the function. Now right now we don't have any parameters to our main function, but later on we may. So and then attached to this function header is a block of code, and that block of code is run when the function is called, just like an if statement really. So same concept as the block of code. The only difference is between an if statement, something else that has an attached block of code, is we can return inside of our function. So many times we would do something like this, and we'd say return 0 at the end of our function. And if we left that off, remember we get a warning something like this: control reaches end of non-void function. So whenever you say int or double or any other data type that you're going to return from a function, the system expects that you're going to return something. So you need to return 0. Now I don't remember exactly, I think it's this. Yeah, so this isn't really important or anything, but it's worth noting where this data goes. So when you say return 0 here, I'll change it to say return 1. So compile it, run it. So that 1 that's returned is actually returned to the system. So let's say another program ran the program that you wrote. It could see, you can return essentially one value describing whether or not the program ran, what kind of conditions it ran under, how it ran to the system. So if, let's change that to 5 or something. Compile it. And we can see that 5 was returned to the system. Not particularly important, but you should realize that that return 0 at the end of the main function does have a meaning. It does have some value. And it's doing like functions would normally do. It would return a value as required. So let's say we're just going to have we're going to write a function. It's going to return an integer. No parameters right now, and we'll just say return 10 or something like that. And then we will just print that out in our main. We'll come back here. Here's what we'll do: int val. Or no, we can't do that. We have to do a equals val. Okay. So either way, we could do that. Anywhere you can put a literal value, a variable, you can also put a function which returns a value. That's also valid. But for right now, I'm going to do it like this. So we call the val function. We go up here. We see this return 10 statement. So we take that 10 from right here. So think about this. Think about that becoming 10. So the right-hand side becomes 10. And we store that 10 inside of A. And then we go ahead and print that off. So we got 10 there. So let's apply some of the things we've learned so far. Let's generate a random number from our function. So what we're going to do is we need stdlib. For the sran function, we need time for the time function. So we're just going to seed our random number generator with the time. And then let's do this. Let's say, we'll say int my rand range. So remember, we already seeded the random number generator. Regardless of the context of our program, wherever we're at, the random number generator is going to stay in the same state. So all we have to do is do that one time for our program. So let's say we want our range to be, let's do 0 through 100. So say rand, and then mod 101 to get 0 through 100. And then to return that, we say return gen. So it's worth noting, just like anywhere else, this can be a variable, could be a literal, or it could be a statement. So we could simplify this code down, and we could say something like return rand mod 101. That's also perfectly valid, but just for kind of clarity's sake, we're going to keep it like this. So let's say we wanted to generate a bunch of random numbers of the same range, and we already know the range, and we want the range to be the same every time. Doesn't need to change. We could kind of put that in a function. Let's say we want to generate 10 of them. I'll just make a little loop here. Missing a parenthesis there. So we can see we get 10 numbers. So what's great about this is we could use this in multiple contexts. If we wanted to say, we could let's change this to be a, let's say rand 100. And we could use that in a bunch of different places. And obviously, like, just using it inside of this for loop doesn't really give us any advantage because we only use it once. We could write the same exact expression right here a bunch of times, but let's say we had a bunch of different if statements, a bunch of different unique blocks of code. If we wanted to use this same statement a bunch of times and it always had the same meaning, we could put it in a function to reduce the clutter of the code and so on and so forth. Again, what we can do is if we have our code inside a function, we can modify everything inside the function without changing anything. So let's say we wanted to do 10 through 110. We could just add 10 right here. We would never have to change any of the usages of our function. It's always going to change the code that's up here. Or it's always going to change based on the changes we make here, and we don't have to change anything over here. So we'll talk more about why that's important later. So that's kind of a very basic introduction to functions. Anything you want me to talk more about right now? All right, so we're going to continue on. So, all right. So talking more about the parameter list. So this is kind of wrong. We'll just skip that for now. So just like, so when we use printf, one of the things we do is we separate things by commas. So the first argument is the format string, and then all the things that we want to replace in the format string. So we've already had some practice working with the parameter list, but we've only ever used the parameter list passing data to functions. So let's look at this simple add function. So what it does is it takes two integers, and then it adds them together and returns the result. So let's go in here and I'll block comment all this out. Don't really need it right now. So res equals lhand plus rhand. I'm just going to go through here and type out the code really quick. Okay, so what is happening here? So we start here, we declare our variables. We have 10 and 20 inside A and B respectively. And then what we do is we call the add function, and what we say is this is the first parameter. We provide the value of a as the first parameter and the value of b as the second parameter. So when we call something with parameters, we go up here and we look at this function. So what we do for the first parameter, so we take the value right here and we store it inside of this LHand variable. So for the second parameter, we do the same. We take the value stored inside of b and store it in this RHand variable. So now, inside of this function block, or inside of this block of code, we can use those variables as much as we want. So let's just run this really quick. And we can see that we got 30 by adding 10 and 20. So I think I had an example over here. So I had slightly different variable names for this example, but it's exactly the same example. So we take the value here, so a is set equal to 1. So we pass the value of a in. We store it in this a over here in the function. So no matter, one thing worth noting, no matter what this name is, the name doesn't have to match the name of the thing you're passing in. All we do is take the value of the first thing and store it in the value of the first thing right here. And the same goes for the second and third. And we can have any number of arguments to pass to a function. The only thing that matters is that they're separated by a comma. So the other couple things that matter are the data that you pass in. So this a right here has a type. The type of a is int. So when we pass a into the add function, it has to match the type of the first argument, and so on and so forth. If we did something like this, if we changed it to double, I don't think this should work, but it might. Yeah, unfortunately, it does. Let's say we had a character A or something like that. Maybe that will work. Yeah, wait. Initialized. Because I guess we can add characters and integers. That's fair. So we'll ignore that for right now. But generally speaking, whatever value you specify here, the data type has to match up here. Generally speaking, you might be able to work around it, but again, generally speaking, that's what you need to do. So here's a couple other. Well, do I have a list up here later? We talked about returning already. So here is a big list of things that you need to use when we're talking about functions. So one of the things I said before was that think of functions as aliases for blocks of code. So you could take something and put it in the function and be exactly the same. And I said that was a very simple case, and it is, because there's a whole lot of things that happen when we use functions. So the first thing that we need to think about is that variables passed in are not modified in our functions. So what I'm saying by that is, so we provide this value of a. It's the value of a, whatever stored in a, is then stored in this LHand variable, and then that's usable inside here. So what you might think might happen is if we went inside here and we did something like LHand plus equals 10. So since we pass the value of a in, since the value of a is stored in LHand, it would make sense that we would be able to modify the value of a. So the value of a being 10, it would make sense that we'd be able to modify that 10 and add 10 to it. But that's not in fact the case. So let's go back here and let's say a is this, b is this, res is this. So we can see that a, b, and res were never modified at all. Or, I mean, res was, but that's just because of the return result. So we can do as many operations on these variables as we want. but it doesn't matter. It's not going to change anything. So this isn't the way it works, but think of it this way. So we have this A here, we have this B here. When we first execute this code, think of this as happening. So we're taking LHand, we're making a new variable. Well, let's do it right here. So we make a new variable LHand, and we store the value of A inside of it. So storing the value of A inside LHand doesn't link those values in any way. It just takes the value and it copies it into a new variable. Same with RHand. We take the value of B, this B stored outside, and store it in LHand. So yeah. So the main reason, I should probably talk about this too. So the main reason we need to pass parameters into functions is because when we call a function, we can't reference any of the variables outside of the function. So we would consider, let's say we're right here, our code's right here, or we're running right here. We would consider that A, B, and res are outside of the function. But if I tried to do something like this, if I said A equals 10, let's say, let's add 10 to A. It would say A undeclared. And what that means is when we're inside this function, the only thing that's visible to us is the variables that we have either declared or the variables that have been explicitly passed in. None of the variables from our old scope, we would say. So when we're executing, we consider this. If we're let's say we're right here, we consider this entire place our scope. None of the variables from the scope, the old function that we were in, are currently visible to the function that we're currently executing in. So we can't reference variables outside of the function. So that's why we need to pass things into the function so we can manipulate them, do operations on them, things like that. So that covers variables passed in or not modified. Yeah, so I've only talked about integers so far, but we can do things like this. We can say double if we wanted to. Change all these things to double. That's completely valid. You can mix and match. You can have ints, you can have doubles. You could have nothing. You can have everything if you wanted to. You could have 10 million arguments. You could have 0 arguments. Just remember that it didn't used to be this way. It's gotten a lot easier more recently. But just remember, if you're passing an integer in here, or passing a double with a decimal, let's say a decimal component, let's say you're passing in a decimal component into an integer, just remember the traditional rules of passing integers, passing decimals. If you pass a decimal and you store it in an integer, you're going to drop the decimal component. Same thing as if you return an int, even though you're working on a double, you're going to drop the decimal component. Take a double, you store it in an int. Take an int, store it in a double. It doesn't have a decimal component anyway, so you don't really care. So keep that in mind, is that you could have whatever data types you want. Anything we've talked about in this class is fair game for the parameter types or the return type. It's all good to go. So we talked about this already. So variables you declare, well, no we haven't, I guess. Variables you declare inside the function disappear after use. So we have this LHand variable, this RHand variable. We have this res variable right here. Once we leave this function, let's have a unique variable name here. So we'll call it my variable, and we'll set it equal to 10. So once we leave this function, this all disappears. All of these things disappear except for the value that we return from the function. The return value is the only thing that's saved from the function after we return from it. So if I try to do something like this, if I tried to reference my variable outside of this function, so remember what's happening is we're starting here. Once we see this line, we jump up over here and we execute down, 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 down until we hit a return statement, and then we come back and then we execute the next line after that function call. So looking at that, again, just like before, we get error my variable undeclared, first use. So again, what we can't do is declare a variable inside here and then reference it outside of the function at all. You just can't do that. Variables that exist inside here only exist for the time that the function exists. Alright, so this is a little flaky. Again, not necessarily sometimes required. It's hard to say. But functions need to be declared before main and before their use as well. So one of the things I haven't talked about quite yet is that you can use functions inside other functions. So you can say rand 100 right here if you wanted to. You can put as many functions inside each other as you want to. But for right now, we can't do something like this. We can't say add inside another add. The reason being is when we see this add right here, we don't know where to go because when the compiler processes this function, it sees a function that it doesn't understand right here. So let's say you're building this language from a compiler standpoint. It starts here, it sees we're processing add, but it doesn't finish processing add until we've reached the end of the function. So we can't necessarily do this right now. There's ways to get around it, but we're not going to talk about it right now. You can't call the same function either inside itself or before it was called. So we can't also do this. We can't do that as well because if we're processing from top to bottom and we're processing this function right here, when we're initially building the program, that is, the compiler hasn't seen the add function yet and doesn't know where it is, so we can't do that. If all of this code was instead below the add function, that would be perfectly fine because we processed from top to bottom. We've seen the add function before. The computer knows what it is when we reach it down here and can use it. So same thing goes for main. Just as a simple rule, just keep all your functions above main and you should be fine. So you can't declare a function inside another function. Notice how all of these functions are all the farthest to the left they can be. They're not inside the main or anything like this. They're not. You can't do something like this. Well, you might be able to, but it's garbage and you shouldn't. You shouldn't do this, or you can't do this. I don't know. Can you do this? I'd be disappointed if you could. Yeah, I guess you can, but you shouldn't ever, under any circumstances, ever put a function inside another function. Because it just, okay, you could do that. Let's say you could do that. So let's say you had this function inside there. What that means is you can only reference it inside the same function. So I could say, like this, void ASDF, and I could call it anywhere inside here. But I couldn't go outside of my function and call it again. Just kind of stupid. You don't need to do that. Just make sure your functions are outside of your main all the way to the left, and you'll be good to go. So you can return at any point if you want to inside of your function. So let's say we are going to do a couple different things. Let's say if lhand equals 0, then we're just going to return rhand and simplify it because we know that addition isn't going to do anything additionally. So we can just return like that. So we can return at any different point in our code. So there's a return statement here. There's a return statement here. So just remember that if we hit this return statement here, our execution immediately stops and we continue on. So let's say we change our a to be equal to 0 and we pass that in. So a is going to be 0, b is going to be 20. So we go up here. We store our a, which is 0, inside lhand. We store our b, which is 20, inside rhand. We come down here, test this condition. Lhand is in fact equal to 0, so we're going to immediately return rhand. So we skip the rest of this code right here. All of this code is skipped. All of it, all of it, all of it. And then we come down here. So we returned rhand. So our rhand in this case is 20. So the value returned from this. So again, think of this entire component right here as being replaced with 20, and that 20 would be stored in res. So that's kind of an example of conditional returns. If you're doing different types of operations, let's say you have a function which does different operations, you could have like, you could pass in like an op, and you could say if op equals 0, then you're going to do some stuff here. If op equals this, you're going to do some stuff there, so on and so forth. You probably want to break that up into individual functions, but that's just an example of how you could do it. So let's do, okay, back. So when we're using a void function, there's one more thing that you should know. So a return statement is completely optional inside the void function. Normally what would happen is you just reach the end of the function and you'd be done. But what you could do, you could say if 10 equals 10 or something like that, you could return at any point. So when we're inside a void function, a return, we use the return statement, but we don't provide any value because we're not returning any value. So just like that, if we wanted to detect some specific condition where we wanted to immediately exit and skip the rest of the steps. So when inside a void statement, or when inside a void function, the return is completely optional, but you still have the option to use it, and you just have to remember that you don't provide a value because you can't return a value from a void function. You can't do something like this. And you're going to get a big ol' error on that one. Yep. So it'll say void value not ignored as it ought to be, because there's no value to be returned, so you can't do that. All right. And then finally, you can optionally return you can optionally ignore the return value from a function. So let's say we have this addition function. It was traditionally written like this, or the add function, I should say. What am I saying? It was written like that. So actually, we don't have to store the value at all. It's completely pointless. But let's say we wanted to just do some operations, and maybe we wanted to get the value, maybe we didn't. So let's say let's clean all this code up so it's a little more readable. Let's say our add function both printed the result of the addition and returned the result as well. Maybe we wanted to do something with that result, maybe we didn't. So we'd say res is res. So that's, okay, let's go back really quick here. So this is the warning you'll get if you have a function used above where you've declared it. It'll say implicit declaration of function add. So compilers are smart enough nowadays to be able to work around that. But again, in order to get rid of that warning, see I have this add and it's above my add right here. You need to just put your functions above where you're using them. So res is 20. This is printing inside the function. Remember, this is printing outside of the function. But just remember, you can always ignore this value. You don't have to store the value returned from this function, which returns an integer. It's again completely optional. We're just not using res. I don't care. So here's we'll spend some time actually talking about this. So I talked about initializing to 0 the other day. This is a great example of why you need to initialize to 0. So you see here, you have this int res, and you might be like, oh, it's totally 0. It's been 0. It's most of the time it's 0. But you look over here, we're getting this random number printing out. Why are we getting that? You just need to set 0 right now. That's all you need to know right now, is that you just need to set 0, or else you might get random garbage. in your program. It's perfectly fine, again, to take a variable. If you don't set it to 0 right away and you set it to something later, but let's say we wanted to do something like this. Let's say we wanted to add a number to res plus equals 10. Just remember that if we don't set that to 0 to start off with, it's not guaranteed to be 0. It just might happen to be 0 under certain circumstances. So, last thing about functions here is that we can leave off this, the value. We don't have to store the value from a function. It's completely optional. So you could write this function to print it, and then use it, or not use it, or do whatever you like. So I think I had maybe one more thing I wanted to talk about. Okay, I guess we're good to go. So for the rest of the class, what we're going to do is work on this in-class assignment. So what I want you to do is write a program with one function for each of the following items. So each of your functions should just be named what each of these things are doing. Reference, I'll post this PowerPoint right after I'm done talking here. Reference this basic addition function right here. Reference that as kind of a grounds how to approach other problems. But write a function which does exactly like the addition function does for all of these different operations. So at least for add, subtract, multiply, divide. So for each of these, you need to pass in two numbers, do the operation, and then return the result. And then in your main, you need to print out what the result was. So there's also a couple of different functions. So there's hello, goodbye. Just write a function which prints hello, prints goodbye. And then you need to write two functions which compare whether the first argument is larger than the second argument, or the first argument is smaller than the second argument. So you pass in, there should be an if statement. If left is greater than right, for your smaller, if left is less than right, and so on and so forth. So if a computation or comparison is occurring, so that's for add, subtract, multiply, divide, larger and smaller, the function should return a value. So remember, we can just return 1 for true and 0 for false. If you want to use stdbool.h and say return true and return false, you can do that as well. And then print the return value from the function inside of your main. So remember, if we're using stdbool, that's not it, we can use the bool type from a function. So we could say bool, not bool is true. And you could say something like return true, if you so choose. But you could just use an int. You could do the same thing by saying int and by saying 1, if you so choose. Either way is essentially equivalent. So that's all I have for you today. So work on that for the rest of class. Have any questions, feel free to ask. Otherwise, that's all I have for you.